Okay, this video is going to be on impulse and momentum. It's related to what we've been talking about with center of mass, although it seems a little bit out of context. So just follow along, and there's some homework problems that are related to this as well. First of all, just a quick review of what momentum was, in case you forgot that. Momentum, mass times velocity, and we call it P. The units, in case you forgot, are kilograms meters per second. So we do lots of problems with collisions with momentum, and we didn't really talk much about impulse last year. The word impulse actually means change in momentum. So it's how much does your momentum change. In other words, you need an impulse in order to change your momentum. You need an impulse, sort of almost like a force, but it's specifically related to momentum. And then, so we can write this up here is change in mv. Turns out that impulse, the symbol for impulse, you'd want it to be I or something like that. Impulse is actually J. So we have J is delta P or delta mv. Let's just do a quick little example. All right, it's very common to do for impulse problems a ball hitting a wall. So there's my ball, sorry, there's my wall, and let's say I've got a ball coming at the wall, and then the ball bounces off the wall and goes that way. I'll just put a couple numbers in here. Let's say we get a 2 kilogram ball, and it's going at 3 meters per second. And then rebounds with the same 3 meters per second. And then I want to figure out how much impulse was necessary to change the momentum of the ball from going this way to going that way. Really easy. J is change in mv. Since the mass doesn't change here, it's just going to be mass times change in velocity. And if you want to write it out a little more formal, you could have mass times v final minus v initial. All right. One of those is going to be positive, one of them is going to be negative because the ball is going one way and then going the other way. So let's just say that we have the mass, 2 kilograms times, oh, I don't know, let's make this one a negative since it's going the opposite direction. So the final velocity was negative 3 meters per second minus the initial velocity, 3 meters per second, right? That's going to give us 2 kilograms times negative 6, and that gives us negative 12 kilogram meters per second. Notice how the units are the same as momentum units. So this is how much the momentum changed. It changed by this much. So that's the ball hitting against the wall. Just kind of a common example to do that. All right, another very common way to talk about impulse is in terms of force and time. Another way to talk about impulse, J actually equals force times time. And we can see this because of the units, right? The units are going to work out. Force units are kilograms meters per second squared, and time units are seconds. So that gives us kilograms times meters per second. Right, so J, impulse, is force times time. So let's just do a quick little example with that. A common problem for this type of impulse problem is to say throw a ball. So here's my guy throwing a ball. Make it a really heavy ball just to make the numbers work out well. It's a 1 kilogram ball. And let's say he puts a force on the ball of 200 newtons. And the time he throws the ball, so the time it's in contact with his hand, so he's throwing the ball that way. The time he's in contact with the ball is usually pretty short. Let's just call it 0.1 seconds. What I want to do here is figure out how fast is the ball going, right? Now if we wanted to, we could just go back and do F equals ma. I could find the acceleration of the ball pretty easily, and then from the acceleration of the ball I could do v is acceleration times time. And that works out fine. But we can also do it just with impulse. and it's pretty easy to do. So we have the impulse, J, that's force times time. Don't forget that's also a change in momentum, change in mv. So once again, the mass doesn't change, so it's mass times change in velocity. And then we can just start plugging in some numbers here. 200 newtons times 0.1 seconds is the mass, 1 kilogram times the change in velocity. So we get the change in velocity is 200 times 0.1, 20 meters per second. So that would be how fast the ball is going. All right, the next video we're going to take a look at graphs of this and see how we can apply a little bit of calculus to it as well.